Hey guys, Mr. Johansson here. We're at the dynamics track. Dynamics tracks are so fun. Let me show you how this works. We have two photogates here, right? On this dynamics cart track, we have something that'll block the photogates. This is called a picket fence. Now on the top, you'll see the dark mark of different lengths, but on the very topmost one, we measured it and it's 2.5 centimeters. All right, so we want to convert that to meters. What do you multiply by? Hope you said 1, all right? Well, you pick the form of 1 that'll change 2.5 centimeters into meters, so we can turn this into meters per second. Once this starts rolling, when it blocks photogate number 1, you'll see a little red light come on there, all right? When it blocks photogate number 2, you'll see a little red light come on there. So you can make sure the photogates are the right height so they'll only be blocked by the top part of the picket fence, 2.5 centimeters. This timer then, this timer is kind of a cool old school timer. When this first photogate is blocked, the time that it's blocked for that 2.5 centimeters to go through it is given here. When it goes through the next one, you don't see a change in the display. Okay, so what you do is you write down the first display here. Write down the first display, first number in the display. That's the time for gate 1. So we could call that time 1, and I'm going to leave room on the top because I'm going to turn this into a velocity calculation, but time 1 is 0.0428. Am I done? Say no. I write seconds. Make very sure when you're doing lab work that you record units meticulously. You have to keep these numbers separate. You have to know which numbers are which numbers, or you will be so lost in the sauce that this starts being cumbersome. Okay? So, T2 then. And actually, why don't we take real data here? So, let's do it the real way. I'm going to roll this. Now, this experiment is not going to be repeatable because I'm just pushing the cart. I'm not doing anything that provides a constant acceleration that I could do multiple times. So you see how we deal with that, all right? Because the bottom line is I want to find what the acceleration of this cart is. So let's see. Reset the photogate timer, and we're off. There you go, all right? I am done with that now, except I don't want it to go and block the photogates anymore. When you put that on the table, make sure you put it on its side because it'll roll right off. So, T1, first time is 0.0380. To find out what the second time is, after I've recorded the first, and only after I've recorded the first, because once I pull the switch, that number's gone. When I pull the switch down, it gives me a memory. The memory gives me T1 plus 2, and that is 0.0766 seconds. What's happened is when this went through the first gate, it displayed the time and held that time in the memory, and then when it went through the second photo gate, it added that time onto the time in the memory. So this represents both times. So if I subtract 0.0380 seconds from that, I will get what the total time is on the gate number 2. So some quick subtraction, 0.0766 minus 0.0380 equals 0.0386. Got to record them with seconds, all right? Again, keeping us from getting lost in the sauce. All right, now notice, on the second gate, it's a little bit longer time. What does that mean? Well, it took a little longer to go through it. So it means it's slowing down. So we're having a negative acceleration. And what could cause that on the dynamic track? Well, there's a little bit of friction, not much. That's not a big change, but a little bit, and that's what we're going to measure. All right, so if I would like to do a velocity calculation, I could do this very quickly. Remember my my 2.5 centimeters. Well, I multiply by 1. Centimeters on the bottom, meters on the top. And what number makes that 1? Well, 100 centimeters in 1 meter. So 2.5 centimeters divided by 100. Okay, so my distance is 0.025 meters. Right? That was the time that that was the distance through which the photogate was blocked. That'll give me a velocity in the first and the second gate. So if I just do 0.025 meters in both cases, 0.025 meters, and I do this, notice it'll give me a velocity, meters per second, right? So then I could say initial velocity, final velocity. And I could do these quick as can be. 0.025, I'm storing that in memory. I press STO1 on the calculator, sort of handy, divided by 0.038 equals, now that is 0.65, and we're going to just take it to 3 places, 658 meters per second. Recall 1, so I have my 0.025 in there again, divided by 0.0386 equals, so the next velocity is 0.648 meters per second. Okay, so I have my velocities now recorded. Now I could get to work. So what are my givens? I have VI equals 0.658 meters per second. VF equals 0.648 meters per second. I'm looking for my acceleration, but I don't have the time between these two photogates. And because I cannot repeat this experiment with the same results, I need something else to work with. What else? Well, I have placed the photogates 30 centimeters apart. Because of that, I could say the distance between which these two velocities took place. Well, that's going to be handy. And that distance is 0.30. I did record it to the nearest centimeter, to the nearest tenth of a centimeter, so I'm pretty good. All right, so 0.30 meters, and I'm looking for my acceleration. The formula I would use, look it up in your reference tables, all right? Why don't we go to the board and do this on the board? I think that'll be a little bit easier, okay? So let's bring the data. Let's go to the board, shall we? Come on. All right, I think we should be able to do this all on the board nicely. So you've seen how to operate the dynamics track. Not so hard. Let me get you up here a little bit. All right. Got my numbers, and we're going to put it into our standard solution methodology here. And V sub I is 0.658 meters per second. V sub F equals 0.648 meters per second. Distance equals 0.30 meters, and we're looking for the acceleration. Right? The formula we will use, if you look it up in your reference tables, well, the formula is certainly going to be VF squared equals VI squared plus 2AD. Standard formula, it's in your reference tables, okay? So you can use that. Well, we're going to be solving for this. How do you do that? Well, these are two separate terms, so let's get it down to a single term first. So VF squared minus VI squared equals 2AD. Okay, so what do? We divide by 2D and divide this side by 2D. We are ready to roll. So S and S, we rewrite A equals VF squared minus VI squared, you following this, over 2D. All right? So take a look at how this solves. Equals, all right, 0.648 meters per second. Quantity squared minus 0.658 meters per second quantity squared, all over 2 times the distance, which is 0.30 meters. That is all there is to it. The rest is just in your calculator. Let's take our handy dandy calculator and 0.648, square it, minus 0.658, square it, press equals, all right? I have a negative number. Why do we have a negative number? We'll get to that. Divided by 2, divided by 0.3, equals 0.02, we'll just round it there, 22. What does this come out to be? Meters squared over seconds squared divided by meters comes out to meters per second squared. So that's our acceleration. And it's negative. Why is it negative? Well, the second gate, didn't it take a little longer to go through? It means it's slowing down as it goes through the second gate. Does that make sense for our dynamics track? There's a little bit of friction. So we're seeing a negative acceleration, which means the whole thing is just slowing down. So that's how you work the dynamics track. Remember that you have to do that funny thing to get the time, that the memory, when you pull the memory button, that's the time for both gates. And so you first record the time for the first gate, then you take the time for both gates, subtract the time that was on the first gate, that'll give you the time on the second gate. That's all there is to it. We could use the dynamics track for so many different things. It's very low friction. You can see that's our acceleration on the dynamics track. That's hardly any acceleration at all. So in other words, it has very low friction, very smooth. It's a really nice, handy device to use. All right? Thanks for watching.